Okay, let's unpack this. Today, we're diving deep into a topic that's really redefining global military strategy. We're talking about the emergence of the B-21 Raider and its ambitious competitors. For decades, air power was often measured by, the physical stuff, how stealthy, how fast. But our sources suggest we're seeing this huge shift away from just the platform itself to something totally different, network-centric air power.
That's exactly right.
Yeah.
And what's really fascinating here is we're stepping into a new phase of strategic deterrence, survivable long-range strike.
Yeah.
It's more critical now than, well, maybe since the Cold War. You've
Yeah.
got China as a pacing threat, Russia trying to regain influence, and the B-21 Raider. It isn't just another bomber. It's being positioned as the flag bearer for this new era, built around its digital DNA.
Digital DNA. Okay, so less like a machine, more like a smartphone, maybe. Constantly updating.
Precisely. That's a good way to put it. Its core is software designed for constant, seamless upgrades. It changes how it operates, how it evolves over time.
Yeah.
We'll definitely dig into what that means for its actual capabilities.
And it's not just the B-21 we're looking at. You've shared some really compelling sources, giving us a look at the main rivals, too. China's Xi'an H-20 and Russia's Tupolev PAC-DA. So our mission today is to pull out the key insights from all this material. We'll look at the B-21's tech, see how it stacks up against the others, and, connect the dots for you on what future air warfare might actually look like. All right, let's start with the star of the show, the B-21 Raider. The sources are pretty clear. This isn't just a B-2 version 2.0. It's something fundamentally new. So what's the big deal? Why was it so desperately needed? What gap did it fill?
That's a really crucial question. The U.S. Air Force, while they were facing a pretty serious capability gap, it was growing. Their bomber fleet was shrinking. Only 19 operational B-2s, right, carrying a massive burden. Think about Operation Midnight Hammer. That simulation needed 7 B-2s for just one strike.
7 out of 19. Wow, that's cutting it thin.
Exactly. And with plans to retire the B-1s and B-2s by 2040, and the old B-52s just not survivable in those heavily defended areas, a big hole was opening up.
Right. And that's where the Long-Range Strike Bomber program LRSB came in, aimed squarely at operating in those tough A280 environments, the anti-accessory denial zones. So fast forward to now, 2025, what's the journey look like? How real is it?
Spot on. Northrop Grumman got the contract back in 2015, and the pace has been, well, remarkable. By early 2022, 6 B-21s were already being built. The first one rolled out in December 2022. Maiden Flight Cerberus, they called it, less than a year later, November 2023, headed straight to Edwards Air Force Base for testing. By September 2024, 3 were flying in the test program. And the really big news, low-rate initial production, LRIP, got the green light in January 2024.
LRIP already? That feels incredibly fast.
It is surprisingly swift, shows huge confidence in the design stability. The Air Force wants at least 100. Some are even pushing for 145 or more.
That is fast, especially thinking back to other big, exquisite programs. And that brings up something interesting from the sources, the B-2 Spirit. Technologically amazing, sure, but kind of a project failure on cost and numbers, wasn't it? Slashed from, 132 down to just 21. Created a fragile force, as they put it. So how did B-21 learn from that? Very expensive lesson.
Yeah, they structured B-21 very differently right from the start. To avoid that exact problem, they set a strict cost target, an average procurement unit cost, APC, around $550 million in 2010 dollars. That was a key performance goal.
So cost wasn't an afterthought, it was baked in.
Exactly. It forced a design that balanced capability with, being buildable and affordable. And crucially, those early test planes, they're production representative, built on the actual production line, not as separate one-off prototypes.
Okay, so no separate prototypes that then have to be translated to a production line later.
Right. The strategy is to dodge that prototype valley of death, get a smoother path to full production. It really shows a shift in thinking at the Pentagon. They don't just want the best possible bomber, they want enough affordable bombers.
The prototype valley of death sounds dramatic, but clearly a real problem they tackled. Okay, shifting gears. Stealth. Low observability, LO. The B-21 isn't just a slightly stealthier B-2, right? It's more than that.
Oh, definitely not just a tweak. It's a significant leap. It keeps the flying wing shape, yes. But look closely. The trailing edge is simpler, cleaner, a sort of W shape, not the B-2's complex sawtooth. It's optimized for high altitude. The whole thing looks smoother, fewer panel lines visible. But the real game changer is the new materials. Radar absorbent materials, RAM, and coatings. They're highly durable, low maintenance. That's key to making it a daily flyer.
A daily flyer, meaning it doesn't need the B-2's special hangars and constant costly recoding.
Exactly. Practical, sustainable stealth. That's the focus.
Okay, Practical and sustainable. Does that mean they sacrificed maybe the absolute bleeding edge of stealth for practicality? Or is it just smarter? And the sources mention multi-spectrum signature management. What's that about? How does it hide?
Good question. It's not really a sacrifice, more like achieving sufficiently dominant stealth that lasts. Multispectrum means hiding from more than just radar. Think heat sensors, visual detection, other electronic means. It manages its signature across the board. Look at the engine inlet slim, blended right into the wing roots, hides the fan blades from radar, exhausts, buried deep inside to mask the heat signature, the infrared, even the cockpit windows trapezoidal, seamlessly integrated, no sharp edges for radar to bounce off. And that light gray color helps it blend visually day and night.
So it's not just radar invisible, it's trying to be invisible.
Yeah.
Everywhere, across the whole spectrum. And broadband stealth, that sounds important too.
It is. Very important. It means the B-21 is designed to beat detection by a wide range of radar systems, including those lower frequency ones that sometimes could, get a hint of older stealth planes. Broadband, or all aspect, means it's tough to spot from any direction at various frequencies. But the philosophy is key here. Operational readiness and cost-effectiveness are prioritized alongside stealth. B-2 stealth was revolutionary, yeah, but the maintenance was cripplingly expensive. B-21's sustainable stealth gets a level of stealth that dominates future threats, but it's durable enough for frequent flights from regular bases. That's the paradigm shift. It makes it far more useful strategically because you can actually fly it more, quicker, and cheaper.
Okay, that makes sense. Which brings us to what the sources call the B-21's true revolution. It's claimed to being the world's first sixth-generation aircraft. We talked about the outside, but this is about the inside, isn't it?
Absolutely. The sixth-gen label comes from its internal architecture, the core concept. Open Systems Architecture, OSA. Think of it. Like, its software and hardware environment is modular. It's open. So you can rapidly plug in upgrades, new weapons, sensors, software, without redesigning the whole plane.
So it stays cutting edge for decades, just through software and module swaps.
That's the idea. It's truly a digital aircraft.
Yeah.
Designed and tested extensively in virtual environments first, a complete digital twin, and the software. Developed using agile methods. That's a huge step for military aviation.
Less static hardware, more evolving system.
Right.
Okay. I saw the term quarterback in the sky used. What does that mean in the context of JADC2, the Joint All-Domain Command and Control idea?
Right. It's way more than just a bomber. It's a vital node in future networks. It can fly high, survive deep in enemy territory, and act as a sensor platform, gathering intel from its own sensors, from satellites, drones, you name it. Then it processes that data and acts as a gateway, or quarterback. Linking up with other platforms using advanced comms, it can even command uncrewed aircraft CCAs, or find targets for, say, an F-35. This family of systems idea just multiplies its power.
Wow. And then there was this other jaw-dropper, optionally manned. That sounds revolutionary for a strategic bomber. What are the implications there?
Game changer is the right word. Being able to send it on the absolute riskiest missions without a crew on board, that completely changes the risk calculation for commanders. Deep inside those A2AD zones, if the mission is too dangerous, you send it unmanned. No risk of losing aircrew, no political fallout from captured pilots. It allows for missions that might otherwise be unthinkable.
So we've hit stealth, open architecture, quarterback role, optionally manned. Is the core advantage just one of these, or is it the combination? What really sets it apart strategically?
It's really the adaptability stemming from that open architecture. That's the core insight, I think. It fundamentally changes the economics and strategy of air power. The competition shifts. It's not just about building a new airframe every few decades. It's about rapid software and payload updates. Yep. An adversary can't just counter the B-21 they see today, because next year it might have totally new electronic warfare, maybe hypersonic weapons, AI mission software, all deployed much faster than they can react with new hardware.
So it creates this constantly shifting, unpredictable threat, forces rivals into a costly catch-up game focused on software and systems, not just metal.
Exactly. It moves the battlefield from hardware primarily to software and integration.
Huge shift. Okay, we've talked brain. Let's talk brawn again. Nuts and bolts. Engines, range, speed, payload. How does this digital aircraft actually perform?
All right. It uses two Pratt & Whitney PW9000 engines, non-afterburning turbofans. 2 engines compared to the B-2's 4. Big focus on fuel efficiency, lower maintenance, range, intercontinental. Estimated around 12,000 kilometers, maybe 7,500 miles, without refueling. They call it a flying gas tank. Lots of internal fuel for its size. Does it hit targets anywhere on Earth, launching from secure bases in the U.S., like Ellsworth?
And speed. I'm guessing stealth won out over raw speed.
You got it. High subsonic. Cruising around 870 kilometers per hour, Mach 0.8-ish, speed was deliberately traded for low observability, range, and endurance. Makes sense. Payload-wise, it's dual-capable. Key part of the nuclear triad, it'll carry the new B-61-12 and B-61-13 gravity bombs and the LRSO nuclear cruise missile. Conventionally, a whole suite of precision stuff. JDAMs, JSMR cruise missiles, even the big GBU-57 massive ordnance penetrator, the MOP, for hitting hardened bunkers, and that large weapons bay and open architecture, designed with future weapons in mind, especially hypersonics.
Okay, so it really covers the spectrum. How does all this tie back to making distance and denial irrelevant, like the sources say?
Well, the extreme range is key. Launch from the U.S., fly the mission, return. No need for vulnerable forward bases. It can refuel midair, of course, but its own range lets those refueling ops happen far from enemy threats, protecting the tankers. And the optionally manned piece adds another layer. For those super risky penetrations, send it empty. It lets commanders accept risks that would be impossible with the crew on board. So yeah, it's engineered to make an enemy's distance and their attempts to deny access basically irrelevant.
That paints a really formidable picture of the B-21. Let's pivot now. Let's look at its global competitors. First up, China's Xi'an H-20. What's the ambition behind this project for China?
Well, the H-20 is clearly about China wanting to complete its nuclear triad, land, sea, and air delivery, and projecting power much further out, past the first and second island chains in the Pacific. It's a huge strategic goal for the PLA. Gives them a credible intercontinental strike option, like the U.S. and Russia have.
Okay, big ambitions. But how far along is it? The sources seem conflicted. Lots of secrecy.
Yeah, heavily shrouded. Development started way back maybe early 2000s, led by Xi'an Aircraft. Chinese officials keep hinting it's about to be unveiled. Unverified pictures pop up online. But then you have U.S. intelligence assessments saying, hold on, maybe not until the 2030s. They mentioned significant engineering design challenges. So is it a deliberate smokescreen from China? Or are they genuinely hitting technical roadblocks? Hard to say for sure.
Right, based on what is known, or at least speculated. How does it stack up technically against the B-21?
Most signs point to a flying wing design, subsonic, conceptually similar to B-2 and B-21. Range estimates are usually between 8,500 and 10,000 kilometers. Payload, maybe 10 to 20 tons. Conventional and nuclear. Some reports claim huge payloads like 45 tons, but those seem unlikely, probably exaggerated.
Yeah.
Now, stealth, it's definitely meant to be stealthy, but U.S. officials seem to think its ELO tech is, quote, far from U.S. platforms, especially the B-21.
So lagging behind on the stealth tech itself?
Seems likely. China probably faces big hurdles with engine tech masking heat signatures is tricky.
Yes.
And also producing those high-quality, durable, radar-absorbent materials consistently at scale. That's tough.
So technical catch-up needed? What about that experience gap highlighted in the sources? That sounds like a non-technical challenge, but maybe just as big.
Oh, it's absolutely crucial, maybe even harder to overcome. China's trying to jump straight to a B-2 or B-21 level aircraft.
Yeah.
Without the decades of hard-won experience the U.S. got from the F-117, B-2, F-22, F-35. Building the stealthy shape is one thing. Operating and maintaining it, that's incredibly complex. The U.S. learned that the hard way with the B-2. Specialized logistics, maintenance, mission planning, pilot training. It's a whole ecosystem.
And the PLA Air Force hasn't operated big stealth planes before, right? Their current H-6 bombers are not stealthy at all.
Exactly. Zero prior experience at this scale. So the U.S. intelligence comment about the human factor is key. Can the pilots, technicians, logisticians actually use the platform effectively? That's a huge unknown. Even if they build a decent H-20 airframe, it'll take years to develop the doctrine, tactics, support, everything needed to make it truly strategic. That experience gap is just as real as any technology gap.
Okay, that's a very important point. Now, let's turn to Russia, the Tupolev PAK-DA. This one sounds like it's been stuck in development hell for a while.
Yeah, the PAK-DA, also called Poslanik or Envoy, it's been Russia's long-running attempt at a new stealth bomber, meant to replace the old Tu-95 Bear and the Tu-160 Blackjack, but it's faced significant delays for years now. The original timeline, service entry, maybe 2025, 2027. That looks highly unlikely now. More realistic guesses push it to the mid to late 2030s, maybe even the 2040s.
And a big sign of trouble is that they restarted production of the old Tu-160, isn't it? The non-stealthy one.
Exactly. Bringing back the Tu-160M production line, that's widely seen as a stopgap measure. It's sort of an implicit admission that the PAK-DA is struggling badly.
And I have to assume the current situation, sanctions, the war in Ukraine isn't helping things.
Absolutely not. Western sanctions have hit hard. They've cut Russia off from critical Western components, advanced electronics, microchips, precision machinery, all stuff you absolutely need for a modern stealth aircraft. Plus, the war is draining the defense budget and straining the industrial base. Funding a super expensive high-tech project like PEG-BA alongside immediate wartime needs, very difficult.
Makes sense. What were Russia's stated goals for the PEG-DA technically, and how likely are they now?
Well, the plan was for a subsonic flying wing, again, drawing from the B-2 concept. They had on some pretty ambitious goals, range 12,000 to 15,000 kilometers, endurance up to 30 hours, payload a hefty 30 tons. Russian sources also talked up its electronic warfare suite for self-defense and carrying new weapons, especially hypersonics, maybe even anti-satellite capabilities.
Ambitious indeed. So with all these hurdles, technical, economic, sanctions, what's the most likely future for PEG-DA? Will we ever see it?
Honestly, there's a high chance it becomes more of a technology form than an actual production aircraft. The combination of challenges makes it really unlikely Russia can build a sophisticated stealth bomber in significant numbers anytime soon. Not in the next 15 years, probably. But R&D on specific parts engines, EW systems, weapons that will likely continue. So, the most probable outcome. Many technologies developed for PAC-TA might end up being integrated into upgraded 216Ms down the line. It's an ambitious dream, but reality is biting hard. Its legacy might just be tech upgrades for the older fleet, not a new stealth fleet itself.
Okay, this deep dive has really laid out the landscape. Let's pull it all together now. Comparing these three B-21, H-20 PAC-DA head-to-head, what are the absolute key differences in their philosophies, their current status? What really sets them apart?
Yeah, if we connect all the dots, two main things stand out, the digital divide and the stealth gap.
Sure.
Status-wise, B-21 is unique. It's flying. It's in low-rate production. Initial operational capability expected mid-2020s. Plans for 100, maybe 145-plus planes. Its core philosophy. Network-centric, open architecture, sustainable stealth. Each 20. Still kind of hypothetical. Development unconfirmed, IOC maybe 2030s, fleet size totally unknown. Focus seems to be range and the nuclear triad. PAC-DA, significant delays, IOC likely late 2030s or even later. Any fleet would probably be very small. Emphasis seems on hypersonics and EW.
So that digital divide, it's really about the B-21 being built for adaptability from the ground up, while the others are maybe still focused on just getting a stealthy airframe built?
Exactly. The B-21's total commitment to open systems, digital engineering, network design, it's a philosophical leap. Its competitors seem to be just starting to grapple with that. They're maybe still stuck in the fifth-gen mindset of the platform itself being the main thing. And that stealth gap is real, too. The B-21 benefits from 30-plus years of continuous U.S. work on low observability. The result is stealth that's not just effective across all frequencies, but also durable, easier to maintain. That's something neither China nor Russia is likely to truly match in the near term.
And you brought up the experience advantage for the U.S. earlier. How critical is that in this bigger strategic picture?
It's possibly the biggest hurdle for competitors, maybe the hardest advantage to replicate. The U.S. Air Force just has decades of real-world experience operating stealth aircraft. Nobody else does. They know the complexities, the mission planning, the maintenance, the logistics, the training. It's deeply ingrained. And the industrial base, too. Despite challenges, U.S. industry has shown it can build the B-21 in numbers. Contrast that with Russia's industry, hampered by sanctions. Or China's expanding fast, sure, but still unproven in mass-producing something this complex and high quality at scale.
And at the end of the day, for deterrence to actually work, it has to be credible, doesn't it? The other side has to believe you have it and can use it.
Precisely. Deterrence hinges on belief. Belief the capability exists, belief it's available in sufficient numbers, and belief it can be operated effectively by trained crews. The B-21's relatively transparent development, its steady progress, that builds credibility. The secrecy around the H-20, the conflicting reports, the constant delays for the PAC-DA, that actually undermines their credibility. Hashtag outro. So the bottom lines from our deep dive today, I think, is this. The B-21 Raider isn't just a new plane. It's a complete integrated sixth-generation system. Its competitors, well, they seem to still be wrestling with the fifth-generation challenge, just building a functional stealth platform. The B-21's real edge isn't just being harder to see. It's built-in ability to see, think, adapt, and command on the future battlefield.
So the whole idea of a strategic bomber is fundamentally changing then. No longer just bomb trucks, as you sometimes hear them called. They're becoming maybe the central nervous system for a wider distributed strike network. And for China and Russia to truly compete, it's not just about rolling out a new plane. It's about building that whole complex operational ecosystem around it. Sounds Yeah, much harder.
Indeed, it's just the new strategic arms race, if you want to call it that, might be fought less in wind tunnels and on assembly lines and more in software labs and network integration centers. And with the B-21 already flying and entering production, you could argue the first shot in that new kind of competition has already been fired.
Which leaves a big question for you, the listener, to think about. What is this fundamental shift away from static hardware towards constantly evolving software and network threats? What does that mean for global stability, for military innovation? And how does this kind of continuous, unpredictable threat change the nature of conflict itself? What new strategies will defense planners need? Definitely a lot to consider. We hope this deep dive gave you a solid head start.